time I have left here. Part one, part one again. I'd like to solve or find the zeros. A few here that I was looking at earlier, before I go back to that. You guys have things on the handout, if you want to look at it together. It looks like this. F of x is equal to x squared plus 4x plus 8. Should have been find the zeros. Now, real quickly, I'll tell you this one will not factor. This one isn't quadratic. Straightforward, going to let u be something. But that quadratic will not factor, guys. We'll go to the quadratic formula. So x is equal to -4 plus minus, and we'll do it quickly. You end up with a 16 minus 4 times a times c all over 2 times 1 is 2. Now to do that quickly, I place the numbers into the quadratic formula. It does not factor it. I'd like to see what is going to happen if everything's been put in there correctly. Okay, let's see if it will work out for me. X is equal to a -4 plus minus. Now, underneath that square root, if I'm careful, is 16 subtract 32, I think. Which is what? -16. Well, that puts me on the alert right there. Professor, I thought you said never have a negative underneath the square root. Chapter 2 opens it up and says you may if you go to a different system of numbers, the imaginary numbers. So guys, this now can be taken further. Square root -16 first, it could be rewritten if you wish, like this. Still over 2, or x is equal to -4 plus minus. And that square root -1, of course, is the I we're looking for in the imaginary system. So this is I, square root 16 we lucked out. Square root 16 is 4. And all that's over 2. So now square root -16 can be dealt with in chapter 2. I don't have to stop and say no solution. Go to the imaginary numbers and we have 4i there. So at this point, we got -4 plus minus, let's write this as 4i all over 2. Now can I reduce that down? Maybe look even better. Reduce everything down by what, 2 here? Or reduce everything down by 2 or divide by 2? Please tell me, does it now look like that? If I simplify or divide by 2, reduce down by 2. Guys, I did it quickly. The zeros are, these are zeros. -2 plus 2i, -2 minus 2i. Are they real numbers? No. Are they part of the solution now, though, in chapter 2? Yes. Okay, guys, so that is the solution. We've got 2 of them. You should get 2. They're imaginaries, have imaginaries in them, and there they are. That's what they look like. Now, the reason I did this one first is when I get back to this thing to finish it up to find the other 4 zeros, the same thing's going to happen, let's say back here when I finish this thing up. So we're looking for 4 more zeros here. Now, x cubed minus 1, if I use that formula, the difference between 2 cubes, guys, my a in this case is what? X, I guess. Just to identify that. And the b is 1. That's right, I got to remember my formula there for the difference between 2 cubes. Put everything in, you're going to end up with x minus 1, x squared plus 1x plus 1, if you're careful. If you use the a cubed minus b cubed formula, difference between 2 cubes, and make your replacements. If you look at it carefully, everything looks good, and there it is. Now, if that's true, then I am now considering this equals 0. Trying to solve and find other zeros here. split this up, just wait, Professor. If you solve this factor and get another 0, you're gonna get 1, which we guessed at the beginning. So you get a 1 for sure, we guessed that. Okay, now, this one's gonna give me 2 more. This is a nice little quadratic. If there's no mistake, and guys, that particular quadratic will not factor. If I use quadratic formula on it, I'm going to end up with, here goes my quadratic formula, x is equal to -1 plus minus square root. You end up with underneath that square root, 1 subtract 4 times 1 times 1, all over 2. We all know how to use the quadratic formula. Let's make sure all those numbers are put in there correctly. Looks like they are. So we end up with x is equal to -1 plus minus. Looks like underneath that square root is -3 all over 2. Is it true? 1 subtract 4? What can I say about square root -3? Before chapter 2 came up, I'd have to say, stop. No solution. Makes no sense. Now what can I do now? Can I go a little further on this? If I rewrite it as -1 plus minus, anyone tell me if I bring in the imaginary, what would square root -3 look like if I bring that imaginary unit I in? Square root -3. Could be thought of it like this. Can you think of that square root -3 as that, guys, or not? If so, is this the I? Square root 3? Yes or no? So a -1 plus or minus I radical 3. I would at least say square root -3 can be expressed as that with an I there. Is it true? Now if I go back and say, hold on, Professor, are you telling me of the 4 zeros that are missing, those are 2 more? And they are. -1, if I separate them, plus I, radical 3, -1 minus I, radical 3. Now, am I done? Did I put those in correctly? Is it -1 plus I radical 3 and -1 minus I radical 3? Are they put in correctly?
Over 2.
Which one now? And over, right here, over 2. Right here. Over 2. Now, how many zeros am I missing now? 2 more. Jeez. How are you gonna find the other 2?
Sum of cubes.
You're going to go back and say, wait, Professor, you also mentioned this one earlier could be rewritten as x cubed plus 8. It will have the sum of 2 cubes. And guys, I don't know how many students remember what the sum of 2 cubes formula was. Does anyone recall what it was? By memory? We know the difference of squares. How about the difference of cubes? I've used the difference of cubes over there. Does anyone recall a formula to refer to for a sum of cubes? A plus B, A squared minus AB plus B squared. You gotta know your formulas for the sum of 2 cubes and the difference between 2 cubes. Now, you guys, I'm not gonna multiply this out, but if you should multiply this out for a check, usually the Strickler's property and so forth, it should take you right back into A cubed plus B cubed. Michael, I'm gonna apply that to this, and at least set it up for us. A plus B, in this case, would be very careful. A is X. What's B? Got you on that one. 2. Why 2? It says what? B cubed is 2 cubed 8. So my B actually is 2. Then when you cube it, you do get that 8 there. So guys, X and a 2 placed in that formula A plus B, that'll become X plus 2. A squared is X squared. Subtract A times B, 2X. That course, b squared plus 4. What a mess. Split this up, and you solve it, you're going to end up with definitely a -2. You say, wait, Professor, we got -2 earlier, we guessed at it. We got it again. And here, left, if there's no mistake, is a quadratic that will finally give me the last 2 zeros. But I gotta use quadratic formula. So guys, here, real quickly, x is equal to 2 plus minus square root. It's like 4, subtract 4 times 1 times 4, I am putting those in quickly, over 2. Or 2 plus minus, someone's about to help me out if I put all my numbers in there correctly. I think I did. That's 4 subtract 16, I think, which is -12. All over 2. And I'm running out of space here, let me bring that to the top here. So this is 2 plus minus square root -12 all over 2. Now, as soon as I see that negative underneath there, I see an I coming in. I see square root 12 also. Does anyone know what square root 12? It's not perfect. What square root 12 looks like? Simplified. 2 radical 3, 4 times 3. Let's put all this together and write it as 2 plus or minus 2i radical 3 all over 2. Yes or no? So far so good? Everything in there correctly? Now can this one reduce down nicely? I think about divided by 2 in this case. It looks like it might be that. In this case. Guys, let me go back and check it. I did it real quickly. Looking good. I think it's looking good. Do we agree? Right? Where am I? This goes into here. Yes or no? If so, those are my last 2 answers. My last 2 zeros. Okay, so this right here is 1 plus I radical 3. This is 1 minus I radical 3. Now, let's hope those are the 6 zeros. Finally, got 6 zeros there. Now you walk in next Wednesday. I don't know whether I would do this to you or not, but maybe you have this. I'm just creating one real quickly. How many zeros are you expecting there? 8. You have to get 8. Professor, that's the exam itself, just one problem. It'll take me 2 hours just to do that one problem. If I have an x to the 10th, you gotta walk out of here and have 10 answers. I did tonight, x to the 6th. And look how much time it took just to find the x to the 6th, the 6 zeros here. Guys, take a close look and see if you accept those zeros. Those 6 zeros. Difference of cubes, sum of cubes, quadratic formula, all this business going on. Yes or no? Are we okay with that? We have those 6 zeros done. Now, before I close down your quiz, short quiz, very short, starts. I need to ask you a question. That is, here we go. This will lead me into next week. On the side here, guys, I'm gonna give you something like this. I'd like to solve this equation. Watch carefully as I'm closing down. I'm gonna lead you into something. Now, if I were a student, after going through this method over here, if I were a student and I found 6 zeros and some had eyes in them, I'd be wiped out, worn out. Then all of a sudden you say, Professor, are you kidding? You're going back to that? solve that, that's a quadratic right now. I don't have to worry about letting u be something, change it into a quadratic form. It will now factor correctly. Go back to there. You guys agree? Those are the factors? And if you split this up, as we do split this up, you're going to end up with this. This is old stuff for us. This is middle school. You're going to end up with those two zeros. Is that true? I did it quickly. Mr. Professor, please, where are you going? Where's chapter 2 going to take me? That's across the street. They're doing that across the street there at the middle school. Here's where it's going to take me. When we see each other next week. Let me plot those two zeros answers. We've got a positive 2. These are like x-intercepts. Positive 2 and a negative 1. There's my x-intercepts. Negative 1, positive 2. Should this graph into a parabola? Should the parabola be opening up? Okay, so it should be opening up. So I'm assuming, with your help, you're saying, Professor, it's got to look something like this. Let me put a big marker here. Slows down. It's got to do something like this, Professor. It's got to pick up those points. This one and this one. Negative 1 and positive 2s are the x-intercepts, so those are zeros. That's got to look like that. Now, can anyone give me a guess? Think of how the phrase is. Oh, this is going to be cute, this is going to be cute, this is going to be cute. Does this particular parabola have a maximum or a minimum value? We're back to local max, local min. Absolute max, absolute min. Does this particular parabola, the way it's shaped, would you say it has a local max, local min, absolute min? Which one does it have? Does it have a local min? If you look at the graph, is there a minimum point on this graph? Is there a point down here that we can consider the lowest of all points somewhere in here? Is that true? I don't have the coordinates, but you think it's there? Now wait, could that point also be an absolute min? So is there a local min and an absolute min on this parabola? If anyone can tell me the coordinates, the x and y coordinates of that local absolute minimum point. That's called the vertex of a parabola. I'd almost say you could be exempt from the exam next week. Show up Wednesday. Oh, exempt. Does anyone think they know the coordinates of that minimum point? I don't think you do. I don't think anyone could right now, I don't think, could label the coordinates down here represent that absolute minimum point on that parabola. I don't think so. But if I did this on the side here, suppose I say this, f of x, I think I call it f of x, or I just said solve. F of x is equal to, now I wrote mine like this. Ready for next week, on Monday. Watch carefully. I'm saying that this, if I have no mistake, write this down. I'm saying this crazy thing is equivalent to this. If it is, we can find this Now, first of all, I gotta verify, confirm. Professor, are you sure if you clean that mess up there for the fractions, it's gonna take you right back into this? X squared subtract x subtract 2. Guys, help me out here. Expand this out, x subtract 1/2 times x subtract 1/2 is x squared minus, does anyone know what's in the middle? X subtract 1/2 times x subtract 1/2, a little algebra involved. Does anyone know what the result would look like? Squared, x squared for sure for the first term. There's the middle term. I'll help you out. Minus x. Does anyone know what's going to go on the end? For x minus 1/2 times x minus 1/2. Last times last. FOIL. What's on the end? If you should actually multiply it out. Is it 1/4? 1/2 times 1/2. And of course I threw in on the end for a reason, minus 9/4. Now if I put these two together, that's 1/4 subtract 9/4, that's what, -8/4? Is that the same as -2? And of course you still got the x squared here, minus x here. Please tell me, is that crazy thing right there equivalent to my original equation here? Now can someone tell me? Oh, let's see how clever this class is. Can someone now tell me, if I think of it as looking like this rather than over there, anyone tell me the coordinates of that vertex, turning point, which in this case is a minimum. Local min, absolute min, if you wish to call it either one. Anyone tell me what the coordinates are? And the rationale why you told me that. Does anyone think they know what the coordinates are? I need the x coordinate, I need the y coordinate, name that minimum point. Does anyone see a connection? Where is Ramsey going? Yes?
Is it -1/2,
Come again now.
is it 1/2?
1 divided by 2? Is that what you're saying? 1/2. You're saying there's 1/2 involved. Hang on. Okay. And what are you going to give me for the y coordinate?
-9/4.
How much?
-9/4.
-9/4. Now, how did he get that? If I took the time to rewrite this simple thing here in a more complex form, like that, he says, Professor, if you put it in that form there, I can see right quickly that minimum point has coordinates about out 1/2, down 2 1/4. Out 1/2, down 2 1/4 is your minimum. How did he get that? How did he get that? Now I just need one word. How did he know if I put it in this form, which looks awkward as you know what? I know this is much, much neater here. But I put it in this form for a reason. What, with one word answer, was he thinking about that we just recently did to get 1/2, comma, -9/4? What's that one word? Transformations. I changed it into a form where you should see the transformation. This right here says you're supposed to move out horizontally, the horizontal shift to the right 1/2. There it is. And a vertical shift down what? Down 9/4. So I have a horizontal shift and a vertical shift put together. There's my vertex. But who on earth? Now the next question is, before I stop here and get you guys started, who on earth would think that this crazy thing here is equivalent to this? In fact, I confirmed it is. These two are equivalent. Who on earth would think, well, wait, Professor, how did you get that? You gave me this, how did you turn it into this? You did some magic there, you turned it into another form. And then I did my shifts and I found them min in no time. The horizontal shift to the right and then down vertically so much. And it gave me the minimum points vertex. Now this is called completion of the square. That sets me up for next week. So in other words, they're going to ask us to please take this. Do something to it, which I have not done yet. Do something to it. It's called completion of the square, and then you'll get this. After I show you the process. I need to be able to answer these questions. Guys, I've talked enough. Mike, we're in chapter 2, we should be. I've got everything put away. No scratch paper really needed on this one. So we put everything on the quick, it's pretty short. But do not rush.